Okay, welcome to JC Connect. In the previous class, we were discussing about the dissolved oxygen experiment. Okay, um, it is very important experiment if you compare with all other experiments. Why? Because the reason behind it is interlinked with many of the experiments. Okay, so DO is interlinked with the BOD experiment. What we are going to do later. Okay, and it is interlinked with the COD experiment, and with this we can design some of the aeration equipments. Okay, pH, it is interlinked with the pH. Okay, and we have discussed how exactly we are going to uh, do this experiment. Okay, the experiment what we are doing, that is Winkler's method. Winkler's method of determination. Winkler's method of determination. Okay. So we have discussed initially. We have to just I'll revise it for about 1 or 2 minutes. We have to take the sample in a BOD bottle of 300 ml capacity. Okay, BOD bottle of 300 ml capacity. Then you have to add 2 ml of MnSO4 plus 2 ml of alkali iodide acid. Alkali iodide acid. Okay, then you have to mix. Okay, so the precipitate is going to form. Okay, very important thing is that if you get the um, light mud color precipitate, okay, then it is a DO is there. DO is there. If you get white, remember, suppose if you get white precipitate, so then DO is absent. But how much it is there, that we have to do it with the help of the titration method. Okay. So if it is mud color is going to form, then mix it well. Wait for about 10 minutes so that all the precipitate which is formed, it is going to settle. So it is going to settle. Once it is settled, once the precipitate is settled, okay, once the precipitate is settled, so dissolve that precipitate using H2SO4. Okay, dissolve that precipitate using concentrated H2SO4. Okay, once it is dissolved, you are not supposed to find any particles inside that BOD bottle. Okay, it will turns to uh, wine red color. Okay, it will turns to wine red color. Once it turns to wine red color, so it is assumed that the TO is present, but how much it is there, we have to find out it with the help of the titration method. Then from that, once all the particles are dissolved, once all the particles are dissolved, then what you have to do is that you have to take 200 ml sample from that BOD bottle. Okay, take 200 ml sample from that BOD bottle. Then once it is if you have taken, transfer that to conical flask. Transfer that to conical flask. Once you transferred it, once you transfer the 200 ml sample to a conical flask, then titrate it, titrate it against Na2H2O3, that is sodium thiosulfate, till you get pale yellow. Remember, till you get pale yellow. Then add starch indicator, it will turns to blue color. When you add starch, it will turns to blue color. Then again titrate it, again again titrate it with Na2H3O3, okay, Na2H3O3, till you get colorless. Okay, so that is the end point. Then calculate the DO using N into V into 8000 divided by 200 ml. That is 200 ml sample you took. So N is normality of the sodium thiosulfate. Then volume, how much it is consumed. This is colorless, very important. Okay, till colorless, how much volume it is going to consume, that you have to note down. Then it is 8000 divided by 200 ml of sample. So this is about the dissolved oxygen. So then chlorides. So of course, this chloride is a very important uh, parameter because it has its own health significance. Okay, so chlorides in natural water can be attributed to a leaching of chloride containing rocks and soils. Okay, first one. So one is may I ask in this way. First one is the what is the natural, how will get naturally this chloride content in water, and one more is anthropogenic activities. Anthropogenic or it is man-made. Okay, so natural means in earth crust. Okay, chloride bearing rocks are there. Chloride, chloride bearing rocks are there. Chloride bearing rocks. These chloride bearing rocks chloride bearing rocks, if it dissolves in water, so you'll get the chloride in water. Normally the groundwater is the source. So in groundwater, if you are getting chloride means it is due to the natural source. Okay, some of the places where you can see in Dharwad district, the Upin Betigeri, it is there. Upin Betigeri is area, one area where even if you dig any borewell, so you'll get the chloride in groundwater. It is due to natural because faults are there or bearing rocks are there. Once the rainwater come in contact with that rocks, they'll get the chloride in water. Next, man-made activities. Most of the man-made activities, it is surface water. If chloride, if you are getting in surface water, it is due to the man-made activities. Suppose if any industrial discharge is there, because some of the food processing industries, okay, some of the food processing industries like fish mills, fish industries, or some of the packaged foods when they are preparing it. Normally, a lot of NaCl has been used. That is sodium chloride, salt. NaCl is nothing but salt. Salt is being used. Okay. So in that industry, you will get, suppose if you are discharging their wastewater, okay, that wastewater to an surface water body. So definitely you'll get the chloride in surface water. Then one more, that is the sewage. From the sewage also, you will get the chloride. So how will get the sewage? Suppose, um, as per the recommendations of the Indian Medical Association or the Indian Council of Medical Research or Indian Medical Association. See what these peoples will say that you have to take only the salt of 5 grams per day. Okay, this is the maximum you have to eat. Maximum, very important. What is happening is that in India, okay, we are up to 25 grams per day per person we are consuming. So almost 5 times. See what our body will do that. Okay, our body what will do is that how much it is required that much it will take and remaining things it will release with the human excreta. Okay, with the human excreta it will be released. Okay, where it will go? Then it will be accumulated in the sewage. That is what the source of the chloride. Not only this chloride, even we have sulfates, you have nitrates. Okay, um, these are the things it is going to accumulate in the surface water body. Okay, and the main health significance is that um, if you consume more salt, so one is very important BP, and second one, the it is more corrosive. It is more corrosive in nature. Okay, it is more corrosive in nature because what will happen is that your bones are made up of calcium. When calcium is going to combine with chloride, so it forms calcium chloride. This is calcium chloride is like a precipitate. Okay, calcium when it's going to combine chloride, the corrosion will start. See, precipitate is nothing but it is a corrosion. Once it is corroded, then definitely um, Okay, when we are talking about the sewage, okay, in the sewage we will get, okay, and this chloride is more corrosive in nature. So how exactly it is going to corrode, or the bone erosion, normally we can call it as the bone erosion. Bone erosion nothing but the formation of the calcium chloride. Okay, see, I said it is going to form a precipitate. Okay, the precipitate is nothing but it is the whatever the bone, from the bone the calcium is come out. Okay, and it is very dangerous also. See, what will happen is that this precipitate, it is going to accumulate wherever the spaces are. For example, bone, in the bone, if any space is there, like wherever the joints, for example, the joints, the space will be there. In that space it is going to accumulate. So then normally if it is going to accumulate, suppose if it is coming out from the blood systems or whatever it is there in our body, nothing is going to happen, but it is going to accumulate in the space wherever the joints will be there. Then it is very difficult. It is very difficult. So there the problem associated with the muscular systems is going to generate. So this is the biggest problem which we will face with the help of this chloride. Okay, then how exactly we are going to measure this in the laboratory? So this chloride is determined by the Mohs method. Okay, with the titration method. With the help of method is titration. Okay, then we are using silver nitrate here. Very important. Silver nitrate as a titrant. Okay, this is nothing but AgNO3. Silver nitrate we are using. The principle is when this chloride containing water, if it is going to react with AgNO3, so it will form AgCl3. Okay, this is nothing but the red precipitate. So once the red precipitate is formed, you assume that the chloride is present. Chloride is present. Okay. So which silver chloride, that is AgCl. This is silver chloride. Silver chloride. Okay. Once this red precipitate is formed, then you can say that it is red precipitate is formed. Means this is the end point. That you have to note down the volume. Okay. Whatever that volume it is there, that you have to put it in the formula. Okay, and here we are using potassium chromate as an indicator. Potassium chromate as a indicator. Okay, so what you have to do is that this is what the principle. Standard sodium chloride is, of course, three steps are there. One is standardization in the procedure. Second one is blank test. Third one is sample. Standardization is to find, I already explained why we have to do the standardization. We have to do the standardization for all the experiments, remember. Okay, for all the experiments, you have to do the standardization. See, whichever the titrant you are taking, titrant means in burette, whatever the solution you are taking, so that you have to standardize it. Standardization means to check whether the concentration is the same as we have prepared. Okay, normally what will happen is that, for example, in the DO, we took Na2S2O3, Na2S2O3. Okay, so we will prepare, for example, we will prepare of 0.025, assume that normality 0.025 N. Okay, this concept of normality and molarity I already explained in the starting classes. Okay, So 0.025 normality if I prepared, okay, with we have some setup procedure is there to prepare it. So to check that whether it will be same after, what will happen is that after long time, this concentration is going to reduce. Sometimes it will become 0.022. Okay, after 15 days or 20 days. Okay, this we have to check that how much it is there, whether it is the remain the same or whether it is decreased. Okay, for that we'll go for the standardization procedure. Okay, most of the time we'll say that it is correct only whatever we prepared the titrant, it is correct, but after 15 days, 20 days or 1 month, this concentration is going to reduce. Once this concentration is going to reduce, we'll we will not be knowing that how much we reduced, how much is reduced. Okay, if you want to determine that, so go for standardization. So standardization is to check that how much concentration of the titrant is there after keeping for some time, to check the concentration of the titrant what we prepared. Okay, so then blank, see, always blank means we are taking some of the distilled water. Okay, um, for this blank process we are in the distilled water, we assume that okay, some concentration of chloride that is there in distilled water during in most of our distilled waters. Okay, most of our distilled water, we assume that the chloride is not exist. Okay, chloride is not exist, but some of the distilled water preparation plants, some trace of chloride it will be exist even in distilled water. Most of the time in blank means in distilled water we'll get zero chloride. But in some of the preparation of the some of the preparation of the distilled waters, slightly there will be exist of this chloride. So if you are using that distilled water for your experiment, so then chloride it is going to accumulate. Okay, in the distilled water. So that we have to deduct always. Okay, and also the reagents which we are preparing, reagents which we are preparing, so we will use the distilled water to prepare it. Okay, we'll use distilled water to prepare it, but we assume that the distilled water does not contain any chloride, but actually it contains, so that you have to deduct it. Okay, so whenever if you finalize the overall the sample or the water where you are measuring the chloride, okay, water where you are measuring chloride, suppose if you got, assume that if you took around assume that in your sample or the water, assume that if you got 500 milligram per liter, assume that as a chloride in the water sample. For this, you have prepared that AgNO3 or silver nitrate, what you have prepared as a titrant. Okay. That for that preparation, you have used distilled water. Remember, for that preparation, you use distilled water. So in that distilled water, assume that it consists of zero point 0.1 milligram per liter of chloride. Assume that the distilled water consists of zero point 0.1 milligram per liter of chloride. This has to be deducted here because we have used the titrant which already consists of zero point 0.1 milligram per liter of chloride. That it has to be deducted. 499.9 is the milligram per liter because it is already exist in the distilled water that we are using it in or most of our the preparation of the standard solutions or preparation of the AgNO3 solution or standard chloride solutions. Okay, then the sample. Okay, this is the importance of the blank test. So blank test is that whether the chloride is exist in distilled water or not. If it exists, that you have to deduct it. The formula is that I'll show you. Okay, if it is not there, no need to deduct. Okay, that is the thing that you have to remember. The standardization, how exactly we are going to do it in the standard solution. So for that we are taking sodium chloride solution, that is NaCl. We are taking of 10 ml, add 2 drops of potassium chromate solution as an indicator and titrated it against silver nitrate solution till the end point is reached. That is changes from yellow to brick red. This is brick red is the end point. So then procedure is repeated until the concordant readings are obtained. Concordant means same readings you have to get. For example, if it consumes 5 ml, the next time also it has to consume 5 ml. So even if it is getting 5.1, then you have to repeat it. Okay, concordant means same value you have to get it. So till then you have to go for the titration. Okay, then standardization is then you calculate the normality of actual N silver nitrate solution using N1 V1 is equal to N2 V2. Okay, that I already explained in the DO experiment. Just go through that how exactly it has to be calculated. Okay, then blank test. Here also what you have to do is that I already said that this has to be conducted for a distilled water. Take 10 ml of distilled water. Why you are taking the distilled water here? To check that whether the chloride exists in distilled water or not. That we are checking. Okay, and 2 drops of potassium chromate solution. The solution is treated against the silver nitrate solution till the color changes from yellow to brick red. This is repeated for concordant value. Suppose if you are getting brick red means some chloride is there. If you're not getting brick red means, okay, chloride does not exist. Okay, chloride will not be there. Remember this. Okay, this is repeated for concordant values. Then, how the chloride is determines that the third step. So we did for A, B, 3 steps. Okay, A is for the standardization, B is for blank test, and C is for chloride determination. So then for chloride determination, you have to take 100 ml of water sample in a conical flask. So add 2 drops of potassium chromate. The same procedure you have to follow here also. Okay. Then titrate again and continue till you get the brick red color. So this is repeated for concordant readings. Okay. So till you get brick red. That is the end point. Brick red color. Okay. Then calculate the chloride using this formula. So normality of AgNO3. This normality what we are speaking, this is actual. Remember, not prepared. Okay. How much actual it is there? Okay. Doing standardization. After doing standardization. After doing standardization. Then this remember here. Then with 35.46 multiplied by 1000. So this 35.4 the atomic weight of chloride. Remember, it is atomic weight of chloride. Then why we are multiplying this one? Always atomic weight will be in grams. That we are converting into milligrams. So grams to milligrams conversion, that is multiplied by 1000. Okay. Then the volume of AgNO3 for sample and AgNO3 for blank. Suppose if you are getting 0.1, I said previously. Here if you are getting assume that 5 ml is consumed, and for blank if it is consumed 0.1, then it has to be deducted. So the total volume consumed is 4.9 ml. That has to be deducted because in blank also chloride is there. Suppose if we are getting 0 here, then total it will be 5 ml only. So then whole divided by this whole divided by, okay, then volume of sample taken. How much volume we took? We took 100 ml sample. Okay, then total chloride, that is equal to V into V. This has to be V means V1 minus V2. So V1 is for the sample and V2 is for the blank. So this is equal to your V. V into N into 35.46 into 1000 divided by 100 ml. That will be in milligram per liter as Cl minus. Okay, this is the unit of chloride. Okay, this is how we have to conduct the chloride experiment. Okay, so here we are using, remember, the titrant which you are taking, that is AgNO3, and the indicator what we are using, that is potassium chromate. and the end point is brick red.